Hello, everyone. Welcome. I guess we are ready to start. So, I said that already, welcome. I hope you enjoy the conference. I hope you enjoy Sofia and Bulgaria. First of all, I want to say big thanks to our sponsors. Without them, the event would not be possible. Of course, the FreeBSD Foundation, our biggest sponsors, they've been supporting us every year, and here they are again. AG Systems, also a long-term sponsor. Big thanks to them as well. And we're lucky to get Trivago on board for the first year this time. And we hope they join us next year again. Google, of course, with us every year. And Google are actually giving away an Acer Chromebook. There will be a raffle. Anyone who wants to join in should open the link, fill in a quiz, and maybe they'll win an Acer Chromebook. The link is also in the programs. Are again with us for the last couple of years. Madison Gurka. As the neural networks. PC Engines, again with us. Eurogame Technology, it's a Bulgarian company, my employer actually. The NetBSD Foundation. So a couple of quick announcements before we start with the keynote. The social event will be tonight at Sofia Hotel Balkan, and will start at 7:30 p.m. Also, we had to make a few last-minute program changes. There will be no FreeBSD Dev Summit reports, but we have 3 news talks on the schedule this afternoon, and those are the talks. They will be on the website in 15 minutes. Yeah. And of course, we are live streaming the event, and those are the links to the web streams. Okay, so enjoy the conference, and I now give you Jordan Hubbard, who will give the first keynote.
Hi, I'm Jordan Hubbard. I'm currently the CTO of IX Systems, one of the sponsors of this conference. And obviously, FreeBSD and I go back a long ways. In fact, I probably should have called this talk looking forward to another 20 years to be symmetrical. But I can't see more than 10 years ahead, and in 20 years, I plan to be dead. So I'm going to talk a little bit about the future. And the title of my talk is a little bit of a double entendre, right? I am looking forward to another 10 years. I think there's some great things ahead of us. But I'm also going to try to make some suggestions and points about what we need to do to be relevant in 10 more years. So I'm going to predict I can't win this either way, because if you disagree with me, you will say that things don't work this way in the open source community. It's a big hobby, and we do what we want. And if you agree with me, you'll say things don't work this way in the open source community, and we do whatever the heck we want. But I hope to change your mind a little bit about that, because I think for many of us here, especially myself, but certainly not limited to myself, this is not a hobby anymore. This has become more than that. And we have achieved more than what you would achieve with a mere hobby. And I think we're certainly all in personal positions where FreeBSD is a lot more relevant to our daily lives. So, but let us first look at where we came from. So, FreeBSD 1.0, November 1st or November 2nd, depending on what time zone you're in, 1993, just over 20 years ago, I did the first as the release engineer, but obviously we're working with many people, 1.0 release of FreeBSD. And this is our 20th anniversary. So we're almost 21 years old now. And as I said, we can drink legally in the US in just a couple more months. Yes. We'll touch more on the drinking theme in a little bit. So this was our first distribution media. Okay, I'm lying just a little bit, but not by much. This was our first distribution media. I remember installing FreeBSD a number of times over a 1.2 megabyte floppy, and that's of course when I couldn't do it over a parallel port because that was faster. That was really high tech. And this had ramifications, which we'll kind of touch on ramifications throughout this talk. You'll notice, for example, that all of the files in the bin dist, and this was true until comparatively recently, is about just over 230K. And that's because that was the size that we could break up the media and fit into both a 1.44 megabyte floppy and a 1.2 megabyte floppy. So in case you've ever wondered why we picked that specific size, it divided evenly into the installation media of the day. And BSD, as it turns out, is full of these little Easter eggs where you wonder, why did they do it like that? Well, let me take you 20, 25 years back, as Kirk can certainly tell us many stories about. This was the 1.0 ports collection, back when it was manageable. You can see Bash is there, so.
Is it vulnerable?
It might have been. We don't know. Can we scooch the projector over a little bit? I think we're clipping off the left edge. I don't know if that's possible. But in any case, obviously some humble beginnings. And this was my first build machine. That actually is not an actual picture of my first build machine. I don't think I ever photographed it, but it's pretty much what it looked like. And it had a absolutely blistering 50 megahertz Intel DX2 processor in it. And I paid, no kidding, $1,600 for the first 1 gigabyte hard drive. I remember when they first came out, and I went and paid cash for it so that I could do builds of FreeBSD. This was the first dream laptop many of us had. This is Warner Losch and I in Japan. That's me touching of Sony Vaio, very lustfully because I couldn't actually afford one at the time, but yeah. Yeah, I was obviously a little lighter back then. We'll touch on that too. And this was our very first conference. As you can see, not much has changed. That is Kirk hoisting a pitcher of beer. That is David O'Brien in the background bringing 2 more pitchers of beer to the podium at the Radisson. I think this was you giving your BSD talk, where you, yeah, and you got progressively more inebriated as the talk went on, but you remained remarkably lucid. I think we actually understood you for pretty much 99% of that talk. But this was at the Radisson Hotel in Berkeley, and it was it's really interesting to think about how humble our beginnings were. I mean, the first morning, the water line to the hotel was cut, so nobody could take a shower, and everybody showed up with their hair all plastered to their heads and looking and smelling not great. And but we had a great time, and we managed to pull it off. And here we are, more than 20 years later, still having these conferences and having them internationally. So I think that's really awesome. So the other thing that has certainly changed is that 20 years ago, our targets in the commercial space, and we did want to be relevant and have commercial users, were ISPs. Pretty much that was at least 90% of FreeBSD's user base. We also did a lot of small and home office web servers and routers. People got a 386 out of the closet with a couple of Ethernet ports and made a router out of it. Very do-it-yourself. I remember from all the traffic on questions. And if we had any major companies at all, that was Yahoo, which remains to this day a FreeBSD shop, and Hotmail, which does not. We also, obviously, were used on a lot of basic developer desktop machines. X11 plus 50 terminal windows was considered an acceptable developer desktop. Again, not much has changed. And the majority of FreeBSD machines were physical PCs that ran on AC power. And that may seem like a pretty obvious statement to make, but again, this is something that we'll come back to later because things have changed. And the key takeaway from this slide is that FreeBSD's role in the world was pretty overt. The brand meant something when you talked about FreeBSD, at least in the network services community and whatnot. It had a certain cachet, and there was a certain brand value around it, and everyone was very upfront about using FreeBSD. So here we are 20 years later. That's a 64 gigabyte USB thumb drive, 64 times larger than the hard drive I spent $1,600 for, and now most of you have one dangling from your keychains, and probably got it free at some conference as a giveaway. It just amazes me, and what you can obviously put on one is just astounding. We don't actually put much more than cat pictures and small installation images on them, but we could do a lot more with these. And this little $35 device, I rounded up to 50 because you want an SD card, obviously, has more power by probably almost an order of magnitude than my first 4860X2. So that is a game changer. And it also means that an entirely different part of the world can do this now, right? This is something you can sell into much poorer countries. I paid a lot of money for my first PC, again, many orders of magnitude more than $35. And the fact that you can now do meaningful development on something like that is again, it's a game changer. And obviously my dream laptop has evolved somewhat as well. I don't have to stroke it anymore, I do own one. And again, this machine has far more power, almost a terabyte of flash storage, huge display density, very powerful multi-core processor. Is just, I can run 5 or 6 instances of FreeBSD under virtualization faster than I could ever have run it on a physical machine before. The poor Sony Vaio just fell by the wayside somewhere. And the other thing I want to point out, which I think is pretty relevant, is that this has BSD included. You may not consider OS X to be BSD in the most classic sense of the word, but there's a lot of BSD in there, and more importantly, there's Unix in there. And when we bought our Sony Vaios way back when we could finally afford them, you basically got Windows on it, or OS2 if it was that long ago, and those were your only choices. And you had to rip off some other operating system to get a Unix desktop. So the fact that we actually have a Unix desktop this many decades after Microsoft did their very, very best to kill Unix dead, I think says a lot about the staying power of Unix. So obviously the current release version is 10.0, working on 10.1 as I believe we speak. There are now 24,000 ports. Somebody asked me if I had known then what I know now, if I would have done it. There are hundreds of committers from both, I'm not going to answer that question. There are hundreds of committers and a lot more, we still have a strong showing in academia, but as I mentioned earlier, a lot more of us are in the commercial world. A lot of us have actually been paid to come here. And that's a very interesting and very telling development that, again, we've grown up. We also, for the first time, have long-term sources of funding. The FreeBSD Foundation, I think, broke $1 million in donations last year. That's real money now. And they're not just standing by themselves. There were a lot of sponsors we saw on that slide a minute ago, and a lot of people putting real sums of money into FreeBSD and sponsoring the development of it, which I think is a really great thing, because there's always going to be a category of really annoying things that nobody really wants to do that much for free, or just in their spare time. And so the funding makes tackling those sorts of challenges possible. But what's also interesting is that the markets have really changed. We're not aiming at where we were 20 years ago, or at least we should not be. And one of the things that's really changed is that the GPL has gone to version 3, and it has created a renaissance in interest in the BSD license in the commercial space. I use that particular animation because I really, you think of kangaroos as nice cuddly animals, and then one kicks you into the water, which is how a lot of people felt when in the commercial world when they followed the GPL bandwagon, and then suddenly V3 came out, and a bunch of technologies that they were reliant on went V3, and there was a whole bunch of new scary language in there that most lawyers, it scares the crap out of most lawyers. I mean, I've been in a lot of meetings with a lot of lawyers where they're going line by line through this thing and going, take it out. So that's actually helped us quite a bit in roles that I'll touch more on in a minute. So one of the areas in which it's helped us is that you're seeing FreeBSD and other variants of BSD or pieces of BSD technology being used in a lot of appliances. Routers, load balancers, security appliances, monitors, file servers, obviously. And it's also the basis for a lot of software appliances, which you can put on more generic hardware. Obviously, I work on FreeNAS, so I had to put it on there, but it's by no means the only one. And if you look at the commercial page at the FreeBSD website, you'll see a bunch of different things there. And as I was surprised to see last year, it's even the base OS for a popular gaming console. So what's really becoming more evident than anything else, though, is that what we used to consider the embedded market was engine computers in cars and avionics computers, things that were really, really small and special purpose, had very limited capabilities, not much memory, and some sort of RTOS that ran on them. But that is really changing overnight. And if there's a key takeaway to kind of set against my previous takeaway, it's that FreeBSD is now becoming much more covert in its usage. People rebrand it, right? Juniper calls it Junos. The company whose name I can't remember right now up in Seattle calls it OneFS. EMC and their subsidiary. Again, if you look at the website, there are probably a dozen different names for FreeBSD now. People just, I don't even know what Sony calls their operating system. They probably don't even refer to it. It's just the operating system that runs in the PlayStation 4. What's that? It's called Orbit. Orbit, okay, well, there you go. Interesting name. But it's not called FreeBSD. And is that a bad thing? Not really. What it is it just says that FreeBSD has reached a certain commodity value that it's useful as a brand name to know what technology, where the technology source is, but you don't have to call your product FreeBSD. In fact, you probably don't want to because you're gonna do a different branding exercise around whatever your product is. If you're a security appliance, you're gonna try and put the word security in there somewhere. If you're a gaming company, I guess space or, and so, again, that's a very interesting development for me at least, because it really does mean we've reached the OS commoditization era where FreeBSD as a brand is both meaningful and not meaningful. And in fact, I've had a lot of arguments with people where they've said, well, you really need to change the name of it because FreeBSD, what is that? Well, free has weird connotations, and BSD, well, that was 25 years ago at some obscure place in California. And my rebuttal is always, it doesn't matter. It's just a brand, right? When we came out with the iPad at Apple, there were a lot of people talking about the connotations of that word. Nobody thinks about it anymore. It is just a brand. And FreeBSD has reached the same place. We don't need to change the name. It's not a problem. So, looking at trends, and I just grabbed this slide from Gartner, and I don't really care for it very much because it kind of tries to put all of this somehow at the iPad's doorstep, and I don't think that's perfectly accurate. Obviously, mobile devices in general are what have caused that curve to happen. It isn't just Apple releasing the iPad on April 3rd. It was probably the match, or the match that lit the gunpowder, but we're really seeing mobile devices take over the world, and that's not going to stop. And in fact, if we look at OS deployments today by sheer numbers, Unix OS deployments, phones are obviously the biggest, tablets, watches. That's an artist's conception, by the way. I have no idea what the actual iWatch looks like. And cables. What? Unix runs in a cable? Yes, as a matter of fact, it does. There are a number of peripherals out there that do video transcoding, DRM, I hate to say, various tasks that require a pretty robust software stack. You don't want to really take an MPEG-4 decoder stack, which is 500,000 lines of code, and put it on top of an RTOS, because it turns out that that code was written on some sort of Unix operating system, and it makes all kinds of system calls and relies on a number of libraries. So as you start kind of pulling on that piece of string, you very quickly find out, geez, I need a Unix in here. Well, it turns out that's not a big deal because there's enough space in those little connectors to put a tiny little ARM chip at each end. And so one of the first things that cable does is boot. And yeah, what could go wrong? You know, I mean, are cables going to have heartbleed bugs, or you know? It's an interesting question. So yes, as I said, the embedded market is really morphing. What you think of as embedded is so embedded you don't probably even realize it. And when we get fully into the Internet of Things, whatever the hell that means, you're going to see even more tiny devices that are in these various ubiquitous roles that you never imagined a Unix operating system being in. But people are going to reach for Unix and stick it in there because it's the easiest and cheapest thing to do. And the hardware's powerful enough. All the reasons that you know restricted you from doing it, like having only 4K of memory or a 1-MIP processor, that is so yesterday. So, you know, talking a lot about mobile here, but obviously the enterprise space is kind of the other end of the barbell, and I think it deserves its own chapter, so to speak. And even there, it's kind of interesting. You're seeing a lot of pressure at what we kind of consider the classic enterprise desktop space, with people bringing their own devices in. That's the BYOD movement people talk about. And it drives IT administrators insane because they have to take this huge array of devices that people insist, and usually by people I mean the CEO, insist on bringing to work and insist on interoperating with their software and working with Salesforce and all the various things. And so for about 3 or 4 years, they fought tooth and nail against it, and finally they just gave up. And so you're seeing that what is considered sort of the classic desktop deployment, even in the enterprise. And I remember an era when people like GM and Unilever had 10,000, 20,000 desktops. They're going the way of the dodo bird. Why? Right? Just take your iPad with you, or your tablet of whatever flavor you like, or your phablet, your large phone, and use it during the meeting. And that's what people are doing. And they can project from it and do a lot of other things. The other thing that's squeezing it from the other end is this whole cloud computing thing is becoming a little less nebulous and a bit more specific, in that if you want to do computation and you want to do storage and you want to do a certain known set of things, the economics of off-hosting to the cloud, and I hate that word because it means so little and so much, is actually becoming pretty compelling. And plus, you're seeing a lot of software vendors, a lot of ISVs saying, I won't sell you a copy of my software any other way. I don't want you hosting this yourself. We're hosting it in the cloud. So you sign up and you pay your monthly fee, and pretty soon, why do you need anything more than a web browser to run the software? The other thing that's kind of interesting too, and I've been noticing this, I had an older friend of mine, even older than me, say that he just got a job at one of those San Francisco startups that are kind of going under the collective description of 2 guys with 2 laptops in a coffee shop. And he was amazed that they were able to do an entire office's worth of work from their laptops in the coffee shop, because every time they committed a change to the code, it fired off this huge chef-driven set of automation which would spin up virtual machines in Amazon EC2 and start various tools running, and they would do regression tests and a whole bunch of things. Then some more VMs would fire up, and it would go to a staging server, and then they would connect to their little URL for the staging server, and they'd look at it and say, you know, click around, use it. Yep, looks pretty good. They'd click a ship it button, and then boom, it would go and deploy. And during the peak of the automation, and they would run a lot of tests. I mean, this wasn't just a fly by the seat of your pants kind of operation. They probably had 50 or 60 VMs running. And so they didn't need a data center. They didn't need a dedicated IT guy. They just had somebody who understood Chef or SaltStack or one of those automation frameworks, and spend a few days or maybe a few weeks or a few months even spinning up all of the automation infrastructure they needed, and then they were done, and they just used that. So again, this has ramifications, which I'll get back to. So no one argues that Unix is basically Lego, right? It's a bunch of composable pieces you can put together in interesting ways, and one of the aspects of Lego is that it's a great general purpose toolkit, and we kind of designed Unix the same way. It's very composable, and we see it as this elegant, awesome, ass-kicking kind of thing. The world sees us more like this, which is just a pile of Lego, man. We're going to take the Legos that we want, and please try to make them all square, and we'll put them together for these automation tasks and these sort of mobile and embedded development things. But of course, they're not all square, because this is really more what it looks like. It's a lot of square pieces and some very specialized pieces that you can't do anything but one thing with. So what's hitting us hard in our insufficiently abstracted Lego universe is, again, the fact that we're carrying around a lot of weight to support physical hardware that really no longer exists in quantity. I think I don't have any metrics to make up on the spot, but I would say that probably the majority of OS deployments today are virtual, if you just counted sheer number of seats. And of course, the devices attached to those are also virtual. So the quality of your virtual device drivers is probably more important, or becoming more important, than the ones for your physical device drivers. Now, there are exceptions, of course. 10 base, or a 10 gigabit NICs and whatnot, or 40 gigabit, or soon 100 gigabit. They have very specific demands that they place on physical hardware. So at some point, you have to run your copy of ESXi or Zen Center or whatever on some physical hardware. That has to work. But everything from there on up is virtualized. And again, to talk about the two guys with two laptops in the San Francisco coffee shop scenario, most of what their automation tools actually do is do their best to erase the notion of a host personality. To take all the configuration information and take it from some other place and splat it on top of a running OS instance. So a lot of the beautiful abstractions that we've built for configuring and for sort of personalizing a box, or even the workflow that we're used to, where we get a copy of FreeBSD on a CD-ROM or a thumb drive if we're a little bit more progressive, and we install it on a physical machine, and we go through all the configuration steps and lovingly tailor it to our needs. That's dead. It really is. I mean, we do it because we're used to it. It's really, really familiar to it. I mean, we kept using sysinstall for how long? So, but that's not how the rest of the world wants to do it. They want to do it in an automated fashion. They want to script it. So getting back to mobile, again, I feel very comfortable in saying that the number of Unix machines running on a battery are now several orders of magnitude above those running off of AC. And they're not plugged. I mean, I'm physically plugged into a few things because I have to be, but again, you're talking to radios now. You're talking to Bluetooth, you're talking to Wi-Fi, you're talking to near-field communications devices. It is a radio, it's an RFI world. And that creates some interesting design pressures on you. Obviously, power consumption becomes absolutely key. If your watch or your phone goes dead after just 24 hours of use, you consider that a very unusable device, or at least you're pretty pissed off that you have to go plug that thing in every night or it's dead the next morning. And because radios tend to make very sporadically, what's the word I'm trying to find here, the quality is variable in a radio signal. And the things like interference and whatnot become real problems, things like channel congestion. So all of these things put back pressure on the operating system to do things like become more agile and hop around, or change the radio's configuration to dynamically seek out the best possible connection opportunities. And obviously, if you're a truly mobile device, you might be doing 100 miles an hour down the Autobahn and continuously disconnecting and reconnecting to different cell towers. So that puts some really interesting constraints on the OS. So one of the less obvious points to make is that trying to debug this and actually diagnose problems in the field also put some real challenges on you. And our telemetry sucks. Our ability to do remote debugging sucks. I'm not gonna mince words. We have some work to do there. Because again, if you're trying to make a genuinely mobile device, you need those things. You will live and die on the strength of those technologies. So I wanted to point out something else that was interesting, because if we look at our open source brethren, one of the biggest desktop providers in the Linux space that I think we can point to now is Ubuntu. They're a huge success story. Mark Shuttleworth opened his pocketbook and basically wrote them a lot of blank checks, and they were able to do pretty much anything they wanted. And if you look at the evolution of their website over the last year, they used to be a desktop OS, and now if you look very carefully, you see cloud, server, desktop, phone, tablet, TV, management, and all of the large panels down there are about how they're ready for smartphones and they're #1 for cloud. They are not skating to where the puck is going, but they're chasing it. They saw the puck go by and they went, whoa, what happened? That way. And we have to do the same. So what that means in technical terms is we need to be really open to fundamentally new approaches. One of the best things that I got to do when I went to Apple in 2001 was get given essentially a blank check on the engineering side. I was told, look, we already pissed off our installed base of Mac OS 9 users. There's really nothing more you can do to them that hasn't already been done. You're starting fresh with OS 10. And do whatever has to be done to make it the best OS for the kinds of products that we want to make. And I took them up on that. We all collectively took them up on that. And we went, I won't say we went nuts. That would be too strong a word. But we took full advantage of it. We ripped cron out. We ripped inetd out. We ripped a bunch of other weird legacy services for mock out, and we consolidated it all with launched. We wrote all kinds of different mechanisms for dealing with dynamic device arrival and removal and power management, and we just went to town. And we knew that we were going to be able to abstract all the system administration issues away through the GUI, or later with iOS, with almost no UI at all, at least not for system administration. And so we were able to fundamentally re-architect big chunks of the system. And that was actually a wonderful thing, because for the first few years, we dealt with all the same reactions that you would expect in a classic Unix environment. You did what? You changed what? You can have my inetd when you pry it from my cold dead fingers, right? We had all the same reactions. It wasn't like everybody was just like, oh, sure. But a couple of years down the line, when everyone saw, gee, I can just launch this by dropping this file into this directory, and I can specify in a very flexible fashion how to scrub the environment and how to launch it in a secure fashion. I don't have to worry about people prepending stuff to my command line. There were a bunch of security ramifications and just ease of use ramifications that came along with the re-architecture that in a couple of years, it was like, of course you do it that way. Why wouldn't you? So again, that's really hard in open source. We have the famous bike shed effect that we like to talk about in FreeBSD, where any proposal that threatens to change the status quo gets bike shedded to death. And I think that's really not as charming as it used to be. I think that needs to change, because to do all the things that I'm pointing at and to move into these markets means some things have got to change. We've got to fundamentally re-architect some things. We also need to be willing to shamelessly adopt and learn from things that other people are doing. We don't have to do this all ourselves. There are a lot of technologies out there that have been practically offered on a plate to the FreeBSD community in the past, and they've kind of said, it's not really our flavor. We didn't architect that ourselves. Yeah, we'll think about it. And then years go past and opportunities are missed. So I think we need to be a lot less proud about that because again, we are a commodity OS now. There's not a lot of point in being truly unique and niche-y anymore. And the last thing is I think we need to be willing to take on some big picture challenges. Back in the 90s when I first started doing this, I used to stand up in stages like this and talk about finding a mountain. And my big analogy was, when you're going on a mountain climbing expedition, it has a wonderfully focusing effect on everybody involved. You got to pack for it, you got to get all the right supplies, and now it's kind of dangerous, and you're climbing up a peak, and it's hard, but it's also incredibly rewarding, and you're doing something that you've never tried to do before, at least if it's the first time you climb that mountain. And it brings you all on the same page, right? You're going to climb that mountain and try not to die. And I think we may have lost sight of that a little bit. I think we need to find some more mountains to climb. We need to pick some big picture challenges that will be hard. Because, when I first got involved with this, I was 30 years old and 30 pounds lighter, and I'm getting old. And a lot of us in this room are getting old, and we need to find challenges that will appeal to the next generation of hackers. And that's something we actually did pretty well in the 90s and the first part of this millennium. It shocks me sometimes to realize that some of the movers and shakers in this project, the leaders, the grand old men, were just starting college when they first came to FreeBSD. They were the young, snotty-nosed kids, right? And now they're not. They have become the new generation and the leaders. Well, that's going to happen again. Again, if we're trying to get 10, 20 years further down the line, we have to think about that now. And thank God for the Google Summer of Code, by the way, because I think without it, we wouldn't even know what interns were. So again, I want to get specific. I don't want to just keep waving my hands up here. But one obvious project idea that we need to take on is to automate a machine, to really run it through all of its paces, cradle to grave. You need to be able to munge its configuration data. And /etc is a septic tank. It is just a whole bunch of weird-ass formats and things that have been there forever and ever and ever. It's really, really time to just toss that out. That's one of these re-architecture goals I'm talking about. And I don't care about the format. It can be YAML, it can be JSON, it can be XML, but there should be a single way of accessing it, reading it, writing it, finding it. And it's really kind of sad that even in this day and age, in the year 2014, if I write a new utility that's going to be a new daemon that runs on my system and I need to have a configuration file format for it, there is no API. I need to write my own Bison parser and invent something and put it in /etc, because why not? Everything else is there. And let's not even talk about the dot files in your home directory, right? It's just architecturally, yes. And obviously, we need to have the cojones to go back and alter all the existing tools to use it. That's the thing that everybody always stops at. Well, yeah, but if I come up with the library and I come up with the single unified format, then I got to go change these things. Change them. It's more trouble to talk about it than it is just to do it. It really is. I've been there, done that. It's not as hard as it looks. Oh. And just to point that out, that it's not as hard as it looks, to use this little machine here as an example, everything in OS 10, whether it's system configuration data, per app configuration data, per service configuration data, it's all an XML plist in a couple of known locations. And that's it. And we hacked the utilities. We did everything required to unify on that. Is it the best format that ever walked the earth? No. Is it good enough? Yes. What's that? No, you just look at Core Foundation Lite and you can, again, steal the ideas. You don't have to take the implementation. There's not a lot to it. There really isn't. And there are probably 50 XML parsers. You don't have to write this yourself. So another thing that needs to be done, especially if you want to work in the mobile space, is you need a centralized notification system. You need to be able to register for notifications. You need to be able to post notifications. Right now, on your average FreeBSD-based appliance, if I even just change my host name, a bunch of stuff stops working. That's really silly. It's one of the first notifications that OS X added was com.system.hostname. You subscribe to that, anybody changes it from any place, boom, you know it's changed. Go do whatever you have to do to your internal state, adapt, move on. Obviously, radio's powering up and down at all times, like I talked about. Network configuration changing because you're moving between cells. Your IP address is changing. Chef or Puppet has gone and whacked a new set of configuration data onto you entirely, and everybody now needs to go and, the world has fundamentally changed. And right now that is done so crudely. It's just you run around, hit everything with a hammer that you think might have been affected and restart it, and there's just no technology there. It's just brute force. And it doesn't need to be. It really doesn't. What you also see as a result of not having a distributed notification system is there's a bunch of things like Active Directory libraries and whatnot that cache information. And since they have no way to do cache invalidation, they break the first rule of computer science. Never cache anything you don't know how to invalidate. Well, what they do instead is they run a cron job once every hour or whatever to shoot the cache in the head. So they do a bunch of work, wasting a bunch of power, and possibly doing needless network traffic to recreate a cache that didn't need to be recreated, or during that 1 hour period when that user got added over there, and now people are going, I can't chown, something's wrong. Well, that cache is still screwing you up. So we really need it. And again, because I want to talk about real examples, here's the Notify API. Notify API was done probably in all of 2 weeks. And a simple Notify daemon, if you have an OS X box, you can send it to SIG user 1, and it will dump all the subscribers into var run notify in the name of the PID status. And you'll see there's just a huge number of notifications. And when we first did this, we probably had 5, 6. In fact, I think we first did it to deal with time zone changes, because we found out there was code in libc that was statting etc local time thousands of times a second. Why? Well, because the time zone might have changed. So it's one of the first things we did is make that a notification. And you'll see, if you can read the slide, that some of those, well, it's too slid over too far, but some of them are, direct point-to-point notifications. Some of them are using a little shared memory cell, so that if you want to poll periodically just to see if your cache is invalid, you can do it that way. It'll send you a signal. It'll do any number of things. It's open source. So again, either use the implementation or just use the ideas. So as I keep mentioning, the whole system startup and service wrangling stuff is, there's an old saying, you can't polish a turd, but you can paint it. And etcrc.d is a painted etcrc. So, I was one of the architects of this stuff. I think I probably checked in the first copy of rc.local, rc.conf actually, because hey, let's add some knobs. What harm can that do? And it's evolved. It's incredibly sophisticated. I've actually looked at the etcrc.d code and seen all the little provides and requires stuff in there, and then seeing how it builds a directed acyclic graph and runs all the things in the right order, and it's like, wow, this is kind of a triumph of brute force over adversity. But it's also wrong. Right? It's just not how you want to do it. You want to do things dynamically. You want to essentially just register and say, hey, when something tries to talk to me, start me up. And I don't want to make any dependencies explicit anywhere. Because the problem with explicit dependencies is they keep changing. And you keep having to chase that dragon. And anyone adding a new service doesn't even necessarily know what they depend on. They find that out by trial and error. So again, I'll talk about that in a second, but I'm not going to suggest launchd because I've beaten that drum enough times. But even the Linux diehards have gone with systemd. They've refactored their system, and it's again just having a broker that you can register with and on demand with IPC or timed events or hardware arrival removal will do the right thing using some metadata to tell it what the service needs to do and what it needs to run is really the right architecture. And to that last slide, if you really want to do power management, you also fundamentally need this because you can't let things run too long. You do need an adult in the room, right? Something that says, you have been running for too long and I can see your power consumption going up. You've run away. And people write crappy code. It's a fact of life. And you're not always going to be able to even control what crappy code gets installed on the system, because there are these app writers who write these apps and they stick them on there and they run them in the background, or they run them from cron or whatever. And when one of those things runs amok on your mobile device, all you know is that the mobile device, which should have had a battery life of 5 or 6 days, had a battery life of 2 hours. And now you're pissed off. And you blame the device. You blame the crappy operating system on that device. You don't blame the errant app because you don't even know that it was errant. Where do you get that information from? What telemetry tells you that it was errant? So you need to shoot it down. Or you need to at least have something that's in charge to report on it. Say, hey, this guy is acting weird. You should probably do something about that. So again, I keep coming back to this. But yeah, we need telemetry. And speaking with my FreeNAS hat on, we're going to do it at IX Systems. We're going to create a telemetry, a daemon, and some APIs for it, and we're going to pretty much instrument the crap out of everything. Because we are at the pointy end of the spear in terms of dealing with enterprise customers who have file servers, which are one of the most critical pieces of infrastructure for people. And when those things go hinky, they rely on us to figure out why. And far too often, we have no idea. We come to the scene of the accident an hour or two after it's already occurred, and all we do is see bodies lying all over the road. And we don't even have things to measure the skid marks with, because there are no skid marks, right? These are virtual bodies, and it's a virtual accident. And so we need better than syslog. We need some way to say, all right, let's look at your telemetry. What was going on in the hour prior to this event? And maybe even what was going on from a couple of different data collection points, because guess what? People break their networks. People have clients that go completely insane at 3 o'clock in the morning, usually on Saturday night, and start flooding, the server with NFS requests or just otherwise acting bizarre. And you can't even always detect that from the server. All you know is you get a lot of traffic. Was that good? Was that bad? I don't know. So usually when you talk about telemetry and remote debugging, a certain 3-letter agency gets mentioned and everybody starts throwing things. Let me tell you something, the NSA does not need our help. They do their data collection much further upstream where it's already pre-aggregated for them. They do not need to attack the individual boxes. That would be a waste of their time. But the users do need the telemetry because again, to keep returning to this point, maybe harping on it a little, we're running in a lot of appliances now. And those appliances, the users just want them to work. And you've probably used 100 products just in the last year where there's a little question, do you want to help make this product better? Unless you're really paranoid, you probably said, sure. Guess what that meant? You signed up for telemetry. So finally on the debugging comment, which I think should be totally uncontroversial, we do need a way of doing IP debugging. And that's another thing that IX Systems is going to sponsor. We have a rough prototype already working, but I'll tell you, I could never have worked on this or the phone without some way of debugging it remotely. It was just insane trying to do anything else. You're not going to always have a serial port or a serial over IP or any of those sort of kludgy ways of getting at debugging. And of course, sadly, FireWire is going the way of the Dodo 2, and that was really cool because you could do FireWire DMA. But it's leaving, so we need to be able to deal with panicked boxes in the field over IP. And that means basically a very simple IP stack that gets used in the times of last resort and says, all right, debug me now. And guess what? When you have that feature, you can also start doing other interesting things, which I've used as well, which is little web portal things that do nothing but say, give me an IP address, and I will go connect for you, and I will scrape that box, and I'll run a bunch of GDB scripts on it, and I'll grab all the relevant information, and I'll file a ticket, and I'll attach the stuff to it, and I'll even tell the triage team, hey, it's still there at the debugger prompt if you want to connect and do different things. And if you don't, well, I got you everything that most people need to debug a kernel panic. So also being able to NMI a box when it's stuck or hung or really, really slow or there's some weird lock contention problem going on, it can make the difference between finding a really pernicious problem that's been annoying people for years and not. So one other thing I've raved about on the project memo list a little bit is I think the SBCs, the Raspberry Pis, the BeagleBones, all of that as porting platforms have been really valuable. I don't want to even sound like I'm disparaging them. I think they're really cool, they're really cheap, they're really useful, and we should keep porting to them. But I think we've reached the level of stability and usefulness with the ARM port that it's time to actually move to real stuff, to a reference phone, to a reference tablet. And I'm not even sure what that reference phone or tablet is yet. There's a plethora of them right now. If you go to Singapore or Hong Kong, you can go to a market and buy 5 tablets for $100. I mean, you know, they're really generic now, and they usually run some weird concocted version of Android or something, but they are getting cheap enough now that at some point we're going to be able to kind of look at the horrible, the not so bad, and the great, and then pick something in the middle, because the great are probably going to be expensive, and say, that's going to be our first reference platform for a phone port or for a tablet port. And the main reason for that is multifold. There are multiple reasons for this. One is, as I point out here, you're never going to know how to deal with real radios, real devices like accelerometers, cameras, et cetera, and so forth, until you actually run on a platform that has those things. And you want to be able to support those things because they're part of what make a phone or a tablet an interesting device to use. Also, being able to carry around a copy of FreeBSD running on one of these reference things means we'll be able to actually validate that our telemetry and our debugging stuff works. Because if you don't use it, and you don't live on it, so to speak, then you're not validating that an end user in that same role is going to have a good experience. And finally, again, using those sort of things will require that we think of a little higher up. We're not just a kernel. We are a collection of services and utilities, and at some point we'll have something for dealing with Bluetooth and dealing with audio and dealing with displays, and all those things are going to have to be part of the software stack. And I think it's time that we tackle some of those things, because again, those are the interesting challenges. FreeBSD should be more than just hacking on kernels. So, to sum it all up, I think we still have some rough edges in not being sufficiently Lego-like. Again, OS is a commodity now. It's been out for decades and decades, so we should make it more usable for the people who want to automate it, virtualize it, stick it in a cable, and not have anything that stands in the way of doing that, or essentially force them to do the subtractive exercise of pulling stuff out. It's one of the first things that people do is have to yank code out of FreeBSD, and that's kind of silly. We should make it possible just to conditionally compile it in the first place. And again, just to reinforce my previous point, we need to pick hardware platforms that are real and relevant. Phones, tablets, watches, cables. Let's find some reference ones and actually start porting to those and see how it works. And because we're going to be kind of late to the party, we should be willing to look over the fence to people who've already done all this. The Androids and the Apples of the world have already been down this path, and they've done a lot of cool technology, some of which is open source, some of which you can just look at a header file and say, all right, let's see kind of what they did in this design, or just watch it work. And you can learn a lot from that and clone it. You don't have to necessarily take the same code. You can create your own independent implementation, but skipping a lot of the hard work and figuring out what it should look like. So, and let me just say that we do have a bit of a rep in being resistant to this kind of thing. That, if you go to the BSD folks, they'll bike shed you to death. They're not going to take your ideas on board. They're not interested. That's a really unfortunate reputation. And I don't think it's entirely merited, but to the degree that it is, we should shake it off and change that reputation. So, in summary, the future is ours if we want it. Thank you.